August 2025 brings Jupiter and Venus dancing together in morning skies, but animals have been using planetary positions for navigation and timing for millions of years. These celestial navigators make GPS satellites look like expensive toys with their incredible astronomical abilities. Loggerhead sea turtles are the master planetary navigators of the ocean with celestial positioning abilities that would make NASA proud. These ancient mariners use magnetic fields, star positions, and planetary alignments to navigate across entire ocean basins. Baby turtles emerging from Florida beaches immediately orient using the brightest horizon over the Atlantic Ocean, which is often illuminated by Venus or Jupiter in the pre-dawn sky. They're basically using planets as cosmic lighthouses that guide them to open water safety. But loggerhead navigation gets absolutely mind-blowing when you consider the distances involved. Adult female turtles return to their exact birth beaches after 20-30 years swimming throughout the Atlantic Ocean. They somehow remember planetary positions and magnetic signatures from when they were the size of golf balls. These living GPS systems can find tiny islands after traveling thousands of miles, using nothing but celestial mechanics and inherited stellar maps. Some loggerheads have been tracked making precise course corrections based on planetary visibility. During cloudy nights when stars are blocked, they seem to rely more heavily on bright planets like Venus and Jupiter for directional guidance. They essentially have backup navigation systems that activate when primary stellar references become unavailable. Monarch butterflies create the most incredible multi-generational planetary navigation system in the animal kingdom. These delicate insects migrate 3,000 miles from Canada to central Mexico using sun position and internal circadian clocks. But here's the absolutely amazing part. The butterflies that make the return journey north have never been to Mexico before. They're following inherited navigational instructions that include planetary timing cues passed down through their DNA. Monarch navigation involves tracking the sun's daily movement across the sky and making constant course corrections based on time of day. They can detect the sun's position even through clouds by seeing polarized light patterns invisible to humans. When planets like Venus are visible during daylight hours, monarchs seem to use them as additional reference points for long-distance orientation. But monarch celestial navigation operates across 4 generations. The butterflies that reach Mexico are the great-great-grandchildren of the ones that left the previous year. Somehow, astronomical navigation information gets encoded in their genes and passed down through generations that never meet each other. Bar-tailed godwits perform the longest non-stop flight of any bird, traveling 7,000 miles from Alaska to New Zealand without landing once. These incredible aviators fly for 8-9 days straight over open ocean using stellar navigation that includes planetary position tracking. They time their departure to coincide with favorable star and planet alignments that provide optimal navigation references throughout their week-long journey. But Godwit planetary navigation involves precise timing calculations that account for seasonal changes in celestial positions. They seem to instinctively know when certain planets will be visible during different parts of their journey. Some birds delay departure for days until planetary conditions are optimal for their specific flight path. Godwits also demonstrate altitude adjustments based on celestial visibility. They fly higher when sky conditions allow better star and planet observation, and lower when atmospheric conditions limit celestial navigation options. Indigo buntings are small songbirds with planetarium-level astronomical knowledge built into their brains. These migrants learn star patterns as juveniles by observing how constellations rotate around the North Star. But they also incorporate bright planets into their celestial maps, treating Venus, Jupiter, and Mars as additional navigation landmarks during their journeys between North and South America. But indigo bunting stellar learning is incredibly sophisticated. Young birds spend time observing the night sky and memorizing how different stars and planets move relative to each other. They essentially attend astronomical school during their first summer and graduate with complete celestial navigation degrees. Some bunting populations show regional differences in celestial navigation preferences. Birds from different breeding areas seem to emphasize different stars and planets in their navigation systems, like having regional dialects in astronomical knowledge. Arctic terns make the longest migration of any animal. traveling roughly 44,000 miles annually from Arctic to Antarctic and back. These master navigators use multiple celestial references including star positions, sun angles, and planetary visibility to maintain their course across both polar regions. They encounter drastically different stellar views as they travel from one end of Earth to the other. Arctic Tern navigation involves seasonal planetary timing. They seem to anticipate when certain planets will be visible during different parts of their journey and adjust their migration timing accordingly. Some populations delay departure until Jupiter or Venus reach optimal positions for their specific routes, but Terns also demonstrate flexibility in planetary navigation. When weather conditions block their preferred celestial references, they can switch to alternative star and planet combinations for continued navigation accuracy. Stellar J family groups have been observed gathering at dawn when Venus and Jupiter are particularly bright, suggesting these birds incorporate planetary observations into their daily activity patterns. They seem to use bright planets as timing cues for foraging activities and territorial behaviors. Desert ants in the Sahara use polarized light patterns from the sun for navigation, but they also appear to incorporate bright planets as backup references when sandstorms reduce solar visibility. They demonstrate course corrections that suggest planetary position awareness during their food-gathering expeditions. While humans need expensive satellites,